Cool. Right. Thank you, everyone. So my name's Richard Tasker. As mentioned earlier, I am a .NET contractor. I have been developing for about 11 years now. My company there, Peer8 Software, hire me. But my kind of main interests have been around HTTP APIs, hypermedia, kind of like later years going into microservices, RabbitMQ, and what I call Dockernetes, which is all the Dockers and things. So, open source contributor and maintainer, helping out with Carter in places, and you can find me occasionally blogging at richardtasker.co.uk. So today I'm going to talk to you about Carter. Carter's a lightweight routing library that sits on top of AspNetCore routing libraries. But we're going to start off with a bit of a little bit background of minimalist frameworks, micro frameworks if you want to call them, and then have a little bit of a comparison between frameworks and micro frameworks. Then we'll kind of have a look at getting set up with Carter, introducing it, and then go through some of the features, and then we'll have some demos, and then we'll have a look at how we can test your modules with the Microsoft something TestServer. I can't remember the exact namespace there. So like any good book, let's start at the beginning. So in 2007, I was frantically cramming for my finals, staying up late, writing dissertations, actually around signal processing, so Shannon's law and fast Fourier transforms, not too distant from me. But additionally in 2007, a DSL for writing web applications, web services, and just general kind of websites was released. This was called Sinatra. Sinatra is a very light framework, or even a library, that kind of sits on top of the rack interface, which again is a minimalist library that kind of sits on top of your different server implementations. This is all written in Ruby. I did Ruby a long time ago. It's again in my distant past. But the emphasis around Sinatra was to be minimalist. You know, there's no, you don't get like ORMs kind of built into it. You don't get kind of like some of the design patterns or principles that you get with like a full framework. You don't even get a project structure unless you create it. It's that minimalist. And this, Sinatra can be actually considered as the kind of like the godfather, the beginning of the rise of the micro frameworks. So we've got, across multiple languages, we've got Express in JavaScript, Flask in Python, Nancy, and I believe Spark is Java. Can't remember that one, but yes, thank you. But this is a .NET user group, so let's talk about Nancy. So Nancy was released in around 2007, 2011. Nancy is a lightweight, low ceremony framework for building HTTP-based services, and as it says there, the main goal of it is to kind of keep out the way, so you can actually go ahead and start developing your applications. And they coined this super duper happy path. And essentially, everything in Nancy works out of the box, from setup. And if you kind of want some extra configuration, that's kind of like the only time you'd step off this super duper happy path. Nancy has took a lot of inspiration from Sinatra, So Sinatra was able to run on different web servers. So can Nancy. So Nancy has this concept of hosts, giving you the ability to run on IIS. It can run on OWIN. It can self-host. It can run across like lots of different web servers. And you know, this at the time was a bit of a game changer. Essentially, the frameworks that were available then were kind of your all-in kind of kitchen sink full frameworks. You know, they did everything, whilst there was no kind of minimalist frameworks there. Nancy literally only provides the ability to handle requests and then send them to your request handler and, you know, return those responses. So now we've got a framework that can run on, can be compiled with Mono, it can run on Linux servers. So this was kind of like the big difference for Nancy here. So what's all this fuss about micro frameworks? You know, why do we want to use one? What are the differences between them, between frameworks and micro frameworks, and you know, what are the benefits of them? So I'm going to try and answer these questions now. So frameworks, you know, a framework can be considered like a collection of libraries coupled with design patterns and principles, whilst a micro framework would be considered like just a library. You know, it will provide a subset of features. With a framework, you get, you know, the handling of requests. You'll get validation. You'll get, you know, data access, authentication, everything that you would need to build a web application. Whilst a micro framework will only provide you the essentials to get you started in handling requests. You might get like logging and some extra little features out of the box, but on the whole, it's a massively cut down version of framework in terms of features. So another thing, you know, a framework could be considered as rigid. They are great because they give you the foundations, they give you the libraries, the tools, everything to kind of build your application. They give you like the scaffolding to put that all together. But if you decide you want to change something out of it, it's actually quite difficult. So if you want to start, you know, using a document database, then maybe, you know, you have to bin off or ignore the ORM that's kind of built into the framework to do that. Whilst micro frameworks are very flexible. You know, they don't give you any tools to start off with. It can be like considered like an opt-in like mentality. So if you want to handle, if you want to, you know, return HTML, then you'll have to extend your microservice. I'm going to say it all the time now. Micro framework to actually be able to return HTML or access a database or so on and so forth. Now, because you get a lot of features within a larger framework, that means you've got actually more things to learn to kind of know the framework, which can, you know, slow your development process down a little. But on the other hand, you know, because the micro frameworks are so minimalist, there is actually not a lot to learn. You've literally got to learn how to set up your project, and then you can actually hit the ground running. Frameworks can be considered very versatile. You can build a CMS, you can build you know, any web application from an API to web services, essentially because you get everything you need to build those things. Whilst a micro framework is very much more targeted, more specific in what you want to build. So there's a couple of key features or benefits that kind of stand out to me with micro frameworks, and that's like the small footprint in terms of like code size, and as I've mentioned, like the flexibility. So because like Sinatra, that was like 2,000 lines of code. There was like hardly anything to it. Because there's less code, there's less layers of abstraction. Just inherently, they are faster and more efficient. Because there is potentially less code that you need to write to actually set up your application. There's less boilerplate code that you need to write, which actually leads to like simpler and more maintainable code going forward, which is then essentially less code to learn. So you can kind of start making your the right decisions that you need to kind of start your development process. And because they provide literally nothing, they are flexible in that way. And as I mentioned earlier, they kind of you have this opt-in mentality where if you want validation, you add it. And because there's so with Nancy, you can actually choose like your dependency injection framework. You get one out of the box, tiny IOC, but then you can actually swap that out to use like AutoFac or Castle Windsor or whatever. You get to choose the right tools for the job that you're in hand. And because of these things, in your kind of like agile process, if the business comes back to you and you have to change your application quickly, the flexibility gives you that ability to actually pivot and go in that new direction. Okay, so I'm missing something. No. So when to use one? Well, as we just said here, you can use them for very basic APIs, JSON APIs, going into hypermedia. Nice little logo for their microservices. And why not? Let's throw in a Docker whale in there because microservices. But essentially, it's probably a good idea to start out with a micro framework if you're going to spin up a new project. As I say, you can add in the features that you require for your project rather than just inheriting all those features like authentication that you may or may not need. But if you know kind of upfront if you're gonna need authentication, data access, and all the features that a framework would provide, why actually waste time extending your micro framework to have those features? Just go with that full framework in the first place. Okay, so just had a quick look at Sinatra, and Sinatra was inspired Nancy FX, and then we just had a quick comparison around frameworks and micro frameworks, and I think the micro frameworks are small and flexible, which is a big benefit. But the only kind of like downside is that you don't get all the features, so micro frameworks need extending. Okay, so over the last few years, kind of when .NET Core and ASP.NET Core was kind of being developed, I think Microsoft took a lot of inspiration from the open source projects that were around. And kind of because of that, we now have a web server, Kestrel, that can run on Linux as well as on Windows. And we've got kind of like the benefits that kind of Nancy brought early on. So recently we had the 2.0 officially version of Nancy officially released. that's probably more than likely going to be one of the last versions of Nancy, just because of where Microsoft have moved to and where what they're providing now. But people still want those kind of minimalist frameworks, and this is where Carter comes in. So Carter is a library that sits on top of AspNetCore's routing APIs. It was created by John Shannon, who was one of the actually core contributors to NancyFX. So a lot of the APIs that are available in Carter are in Nancy. So if you have a Nancy project, it will be very simple to actually convert over to Carter. But yes, this is what potentially the next stage of lightweight frameworks are in .NET Core. So we get model binding and validation with Carter. That's kind of using Fluent validation. We get kind of before and after hooks. We're not going to cover those today, essentially because with .NET Core 3 or ASP.NET Core 3 and how they've kind of re-implemented routing, these are kind of less important now. If you want to learn more about routing and how it works in ASP.NET Core, I've got a link on my final slide, so take a photo. So another feature that Carter provides is the ability to handle the different status codes returned by your modules. So if you get a 404, you can do something specific, or log an error. Now, out of the box, Carter only handles or only returns JSON, application JSON. So there is an interface that you can actually implement to actually extend that. So we'll have a quick look at doing that. And a more recent feature is OpenAPI support. So OpenAPI is a specification for kind of like machine like discovery and kind of like machine-to-machine communication between APIs. So let's have a look at kind of getting started. Okay, so there's kind of two ways to get started with Carter. If you've got an existing project that you want to add it to, there's a NuGet package where you can just very quickly install. But if you're creating a new project, there is also a project template. I have that installed, so let's kind of get one started. And let's just see how long it actually takes to get up and running with Carter. So I'm just going to create a new folder. I just type okay, so I'm going to go .NET. Is that clear for everyone? Yeah. Okay, so we've got our project successfully created. So we can quickly show what we've got in here. So we've got a project file, our home module, program CS, and our startup CS. Program CS and startup CS you probably recognize, as well as the CS proj, but cool. Okay, and now we can just literally just go. There we go. And there's our kind of first, Carter project just there, up and running within literally minutes. So what has been created? Where's that going to pop up? Okay, so if you've done any kind of ASP.NET Core development, this is probably familiar to you. So this is us just setting up our Kestrel server and our startup CS. We've got two methods in here. We've got our configure services where we are literally adding all the dependencies in for Carter, and then we're actually telling it to use Carter as the kind of like framework. And our home module. So we've got, when we're hitting it with our browser, we're sending in a GET request. We don't have any path on there, so it's literally the entry point, and we are coming in and we're writing out to the response, "Hello Carter," but you can't quite see that on the screen. But that's not a very realistic example of how to use Carter. It doesn't really show off any of the features either. So let's come in and go and have a look at a slightly more realistic example. Okay. Okay, so I've got a very simple API here. It's what we've got is essentially it's like an actors database. We've got an actor provider, which is kind of our data access. It uses a dictionary under the hood, but we've got our actor module where we define all our APIs that we want to interact with. We've got some validation in here. And I'm going to show you the status code handler for 404s, but let's go have a look at our module. Okay, so all our modules will inherit off this Carter module. If you do have like a base path, you can define it in this base constructor here. But everything is defined within our constructor of the module. So here we are, we're getting all our GET requests coming in here. So we've got, the first one is just the kind of base / actors. So that will return us all our actors. Next one here is getting out a specific actor from our database. But now we can create an actor with a post, and then we've got similar for updating with put, and then we can actually go in and delete. Our actors. Right. Okay, bear me 1 second. Okay, so coming in here, we can actually see our requests. So we are returning a JSON list of what's that? 4 actors. We've got Johnny Depp, Hugh Jackman, Ewan McGregor, and Mark Wahlberg. And we can actually pull out a specific one. It's Johnny Depp. We can actually come in and create an actor. So here we can create Brad Pitt. So we've gone and created it, but oh dear, there's a typo. Brad Pitt's second name has 2 T's. So let's go and update that. So we've updated it. We didn't get content back. Again, we can come in and then see that list. So we can come in and see Brad Pitt has been created. And there he is. And then finally we can come in and just delete that. And then we should get a 404. There we go. Okay, so what's actually happened under the covers? So back in our module. So one of the important or key features with Carter is this negotiate method. So if we do actually have multiple response negotiators, depending on the actual headers, the accept headers in the request, it will choose the right response for the header. There are different APIs in here, so you could just return this as JSON. Which will just return application JSON all the time, forever. Okay, so let's looking at the post request. We've got this bind and validate method. So as I mentioned earlier, we are using Fluent validation. So I don't know if any of you have used Fluent validation. I prefer it for validation rather than the kind of data annotations. We've got a couple of rules in here for our name and age. We have to just make sure that they're not empty and age is greater than 0. So that will automatically get picked up and validate the object, and if it's validated, bind it and return us the object. If it's invalid, we'll get validation errors, which I can very quickly show you. So if we take out name when we create Brad Pitt, so that's a very quick example of the validation error that you get. So you got your name and telling us that it shouldn't be empty. So earlier I mentioned that we have the ability to handle different status codes from our responses. So here's an example of a status code handler. So we've got this interface pointing on that monitor. The status code handler gives us 2 methods: can handle and handle. So here it literally passes in the status code that is received, and we just say we want to handle a 404. And then here we're going, we can do a multitude of things here. We could actually send this off to I don't know, maybe you've got like InfluxDB or something, and you can write a log or something along the lines. But here I'm just writing the response out. I'm just saying that we can't find a resource at the path that you've requested. So we just quickly restart this. Okay, so now when we come in and try and do our get for Brad Pitt, you should see a slightly different response. So now in our well, that's very small, but we've got no resource found at actor/5. Okay, so one of the other features that I mentioned was the Open API specification, and being able to send out Open API documents from an endpoint. I actually find I haven't used it in kind of anger, but I actually find the Swagger UI very useful, kind of doing local development rather than having to use the command line to send a request or something like Postman or similar. We actually get a UI to do this for us. So I don't know if has anyone used Swagger? Yeah, awesome. I've lost my browser. There we go. Okay. Okay, so here, we've got an example of an Open API document. So we've got title, we've got the different paths that we have in our application. In our API, so we've only got two. We've got /actors and then /actors with an ID. But behind those, we've got two methods. We've got the get, which returns all the actors, and then the post. Within the post, we can actually see what we need. So we need an actor, and it also gives us the details about the endpoint. The response 202. and in similar sort of manner, we get stuff for getting the actors, putting the actors with our parameters, and we can actually get a representation of the actor down at the bottom, like so, down there. But okay, so then this is our Swagger UI. So we've got our list of all our APIs there, and then you can just go in and interact with these. Cool. So to do this, we need to extend our module slightly. So now our methods, so like our get method, our post further down, we've now given it this Swagger document that gives you all the kind of metadata for that endpoint. So there's lots of information you can actually populate in this. I don't know the specification, but this is a nice little demo. But we've got the different responses. So we could put in the 422 for the validation errors in here. If it was on the post and the puts. Again, 404s on the get by ID. We can put that information in here, and just to build out that document, so the different clients, the different APIs interacting with our API would get that information up front. Okay, so I mentioned earlier that I've got a bit of a background in hypermedia, specifically Siren, and I thought that would be a nice little example of how to extend our API to handle or return Siren responses. So what Carter gives us, we get an interface, the iResponse Negotiator. Again, very similar to the status code handler. We get a can handle method and a handle method. So here we are checking the media type that's come in. I've got a couple of methods down the bottom here that just checks what we've got. So the Siren media type is application/vnd.siren plus JSON. So here we're just checking that the after the slash begins with VND and then ends with Siren and JSON. And then using our service collection, we can get our, I created an interface which is our response generator, which have registered in the startup. But here, we're pulling it out of the request services, getting the first one that can handle. So if we had, HTML in there, XML in there, we get the first one that matches our. Apologies. That is for the model. It can handle that model, and then we come in and generate our response, and then serialize that back out. You can see where I've been debugging this over the last few days. Okay, so this is our generator. So I've kind of stuck two together here. I'm generating a response for our list of actors and our singular actor. So here our can handle determines whether it's a list or the singular, and then calls the generate method, calls the relevant generate private method to get our response. And I'm not going to bother you with some of the details of Siren, but here we are just building up our entities. We've got our links and actions are probably, yeah, there they are, just coming in here. So links, actions, links is like a link. It passes you on to the next bit of information that you might be interested in. Actions is what can you do with this entity right now. Okay, so just to kind of compare the two, so this request here was just a regular request that we saw earlier, which returned just regular JSON. This next one here is we've got our accept header, which tells us that we want a Siren body back. And we can kind of see what that would look like. So for this list of actors, we've got our actual actors as a collection, but then we were able to create an actor, and yeah, that's it. So, is there any questions before I kind of move on to the kind of next bit? No? Okay, cool. Hopefully that's kind of going to stick with you. So the last thing I want to touch on is how we can actually go about testing our modules. And I find, you can come in and so like with MVC, way I've done it in the past, you come in, you just create a new controller, set up your kind of mock dependencies, and test what goes on within the controller. I actually prefer kind of a slightly wider way of doing things. So with this test server that I'm about to show you, it gives you the ability to actually run like unit tests that kind of send in a request to your API. You can get a response back. You can test things. Did you get the correct status code? Did it actually return the right data? But then also because we've got control over what dependencies we can inject into our modules, we can actually send in kind of the mock data access classes and actually validate that on a post request, yes, we got our 201 back, but actually this thing also got saved to the database. So this is my test project. We've got it's set out same structure as our modules. So we've got create actor, delete actor, get all, and kind of this way of testing kind of quite opinionated on my behalf, so it might not be to everyone's taste. But I split out my tests into specific classes. So we've got a folder for the create actor request. So when the request is valid, tests, and then when the request is invalid. So we come in and so this is using XUnit. So XUnit is quite nice because the setup can be done in the constructor. So here we've got, I'm using autofixture to create as a fake kind of randomly generated actor, because I'm not really interested in the actual data at the moment. But this is the key here, key area here. So here we've got our test server, and we're using the web host builder to actually set up everything that we need to run our application. So we've got our mock kind of iActor provider, which is done by Fake It Easy. Then we're kind of registering the Carter dependencies and then actually telling the application to use Carter. And then this spits out a HTTP client that we can actually use to interact with that API. So these last two lines on 41 and 42, we are taking our, there it is, our actor, serializing that to our request, to our JSON request, and then posting that in to our API. Unfortunately, because we're in a constructor, we have to play around with not real async await, but okay. So these are our assertions. So here we've got a single kind of test for each assertion. So here that we're checking that we are actually getting a created response back, and we're actually getting a response of the actor. And here then we're actually checking if the call to the database was actually happened. So any questions around kind of like the test server and how we can use this? No? Okay. Okay, so kind of closing things off now. I hope you enjoyed kind of this talk. This is kind of like I quite enjoy using Carter. It's quite like I say, a lightweight framework that is kind of like really easy to kind of get on with. But yeah, in summary, we had a quick look at the history of minimalist frameworks, specifically Sinatra and kind of in .NET land Nancy. And then looked at the differences between a framework and a micro framework. Then kind of went in, I introduced you to Carter, got you up and running, hopefully very quickly. Then I kind of demonstrated how to extend Carter with the status code handlers and the response negotiator. Then I showed you how to, an approach to testing your Carter modules. So with that, thank you for listening. Code is on my GitHub at ritasker/Carter demos. I've published the slides already, so they're on my speaker deck. If you want to get more involved with Carter, we are sat on GitHub, Carter community, the actual project /Carter. If you're interested in learning more about the Siren negotiator, that's already on there, so you don't have to write that yourself. And as I mentioned earlier, a bit more information around routing in ASP.NET Core. Thank you.